Good morning, everyone, and welcome to today's webinar, Secure Your Site with Free HTTPS everywhere with Pantheon and Let's Encrypt. Your speakers for today are Josh Koenig, co-founder here at Pantheon, Ari Gold, product manager also here at Pantheon, and our guest speaker, Josh Aas, founder at Let's Encrypt. Just a few housekeeping items to go over before we start. Please make sure you submit any questions you have during the presentation in the question window or tweet them at GetPantheon. We will answer as many of the questions as we can during the Q&A portion of today's presentation. Also, this webinar will be recorded and the recording will be made available to everyone next week. I'd now like to turn it over to both of the Joshes and Ari.
Thanks, Atusa. So I'm excited to give this webinar. I'm Josh. I'm a co-founder at Pantheon and have been building the internet for about 20-odd years, and really just thrilled that what has, for most of my career, been a rare and special event, being able to put HTTPS on a website, is now the common case. Ari?
So I'm Ari, and I'm a product manager here at Pantheon, and I've worked on this project, Global CDN and Free Automated HTTPS. So excited to dig in with y'all.
Hi, I'm Josh Aas. I'm a founder and the current head of Let's Encrypt. I'm really excited about getting the web to 100% HTTPS and happy to talk about that today.
Great. So the agenda for today was we're going to do a little bit of an overview on the state of HTTPS and a little of the internals and why it really matters. Then we're going to hear from Josh about Let's Encrypt and the sort of their backstory, how their technology works. It's really interesting and exciting and important. And then Ari is going to talk about how we've implemented that here at Pantheon with our global CDN to make HTTPS the norm for sites, and we'll save at least 15 minutes or so for Q&A at the end. I'm sure there'll be plenty of questions. So I'll just dive right in with why switch to an HTTPS everywhere model rather than HTTPS being the exception rather than the rule. Well, obviously there's a security consideration. That's one of the underlying benefits, and this is something that everybody really cares about. And because everybody really cares about that, I mean the big players on the internet, because everybody there cares about security, there are a number of things that are above and beyond that the big players are kind of using as nudges, sort of carrots and sticks, if you will, to incentivize the rest of us who make websites to go HTTPS. So you're starting to see browser behavior that becomes more and more intrusive and aggressive in notifying users when there may be something at risk in terms of submitted content going through an unencrypted channel and so forth. There was a Google recently sent out an email to everybody who uses their webmaster tools, which is most people who have a Google Analytics account, warning us all that in October the warnings in Chrome, the browser they make, will be stepped up. Mozilla added to Firefox warnings at the beginning of the year, and they have signaled, not specifically what they're going to do, but on their blog they've signaled that they intend to ratchet those warnings up as well. So users are going to be more and more informed and potentially alarmed if they're browsing insecure sites. Google also, on the other side of the house, has decided to make HTTPS search ranking signal. So all other things being equal, two websites, one encrypted, one not, the encrypted one wins the search rank war. So that's really important for anybody whose website has a mission and needs to be found. And on the developer side, there are a lot of really exciting features that are coming into browsers, new APIs that are available for JavaScript, people who are developing React apps, people who are developing things that have interesting mobile experiences. Those features are being gated so they can only be utilized by properties that are operating under HTTPS. So if you're excited about the future of front-end development, or you want to get into developing the kind of progressive web app model, really exciting cutting-edge stuff, you've got to be running HTTPS to do it. So to sum up, the end result is it's really not optional. We need to start to move from a world where HTTPS was a special exception you would implement only where absolutely necessary because it was costly and technically difficult and had a performance impact and everything else, to just being the way we do all websites all the time by default. A little about how the HTTPS works under the hood. People often throw around the term SSL, as in SSL certificate. SSL is actually the kind of the deprecated yesterday's protocol, secure sockets layer. It's been succeeded by TLS, transport layer security. And basically what you have is it's two different pieces of technology. One is the protocol, which in these diagrams is outlined on the right with the kind of sender-receiver model. And what you have is actually a significant number of back and forths between the client, right, like your browser on your laptop or mobile phone, and the receiver, which is like a web server somewhere, or in Pantheon's case, one of our nearby CDN endpoint nodes, POPs. You have to like do TCP and go back and forth to figure out how to just send bits back and forth. And then the first thing you do is you exchange some secure bits to set up an encrypted channel. And then after going back and forth 3, 4, sometimes 5 times, you can actually start transporting the application data. And on the left-hand side is the sort of the structure of certificate authorities, right? Like encryption in and of itself doesn't really, you know, it implies like that your data will be not visible to people who are in between, but it doesn't really tell you who to trust and how. So the whole certificate authority regime is based on this idea of a chain of trust. And there are a very small number of certificate authorities at the center of that chain. It really started with like 1 or 2. It was kind of a cartel. And that's gradually grown over time, and now, you know, which was really great, includes Let's Encrypt. But you know, it started as a very rarefied kind of thing, like a sort of bureaucratic process by which you would obtain a certificate, which would sort of be your certificate of authenticity. And then as the web expanded and we realized that this wasn't going to scale, you have this idea of intermediary authorities. So like, you know, Verisign can grant certificate granting authority to someone else, and you say, okay, because I trust this person and they're trusted by Verisign, now I know this is legit. And that's why if you've ever deployed HTTPS or deployed a TLS certificate, you know, sometimes you have to deploy this intermediary certificate along with it, particularly if you've gone with one of the lower cost certificate authorities that does this at scale. Most of them are they're an intermediary from some other higher up. So this is like, you know, fairly complicated, but TLS is the future compared to SSL. It's got better performance. It has fewer round trips than SSL used to. It's actively maintained, so like from a security standpoint, you've got to be using that. But it is kind of complicated, and it can be something that if you don't deal with it frequently, can really trip you up. So just talking about what is actually secured by HTTPS, I think this is important because oftentimes, you know, with the browser warnings and so forth, people think passwords. They're going to get my password. Or they're going to get my credit card number. And that is certainly a concern, but actually there's an enormous amount of other data that's just passively available, sort of metadata from your browsing interactions that are really risky if insecure. So here's an example of 2 different web requests in the form of like, if you make a Freedom of Information Act request, what you could get back. On the left is what you get back from an HTTPS transaction or HTTP transaction, which is everything. We know who sent it. We know where they went. We know that they were not just going to WebMD, but we're looking for some specific medical information. We can read all their cookies. If there's a, you know, in terms of being worried about people sniffing out passwords, session cookies are much easier to steal because they're sent with every single request. You don't have to like magically grab the password. Any web request will have the session cookie in it, which is just as good. And actually, the final thing is you don't necessarily even know if you're really talking to WebMD. You're vulnerable to what's called a man-in-the-middle attack, where somebody, you know, could be at your ISP, it could be at the telcos in between, is able to say, intercept the traffic and pretend to impersonate the property that you're trying to speak to without you necessarily knowing. So when you use HTTPS, you know, you actually have all these things locked down. The metadata of what content you're looking at is not visible to the outside world. All of the headers, including cookies, which is session tokens, but also a lot of metadata that could be extracted in terms of ad tech and so forth, that is no longer visible to the outside world. You have identity validation, like you have this, you know, sort of notary public seal that you have a really good belief that who you're talking to is who they really say they are, and it hasn't been interrupted by a man in the middle. And of course, if you're actually posting data, that's secure too. But the above three are also really big risks to consider in terms of HTTPS, and it's one of the reasons why we want to make it so widely just the norm. And again, if you don't secure these things, like your local network neighbors, which could be like if you're at a coffee shop, anybody who's sitting there, or potentially if you're on a not so well architected cable modem type setup, your literal neighbors. It could be someone at the telecom company, and of course, like anybody who works in a state government agency that does electronic surveillance could be reading this stuff. So we really want to lock all these things down and just make it safe for everybody. And we're doing it. Like, the adoption is really going well, and Let's Encrypt is a huge part of that. Over the past 2 years, basically, we've increased the amount of web running under HTTPS by 20%. That's a 50% improvement in just 2 years. By context, it took almost like more than 15 years to get to that 40% mark. So we're really starting to move the needle, which is great, but it's a team effort. We need everybody to be involved in help making the web secure by default. And Pantheon is playing the part. So I'm just going to steal a little bit of Ari's thunder and play this quick video of how easy it is to get HTTPS on Pantheon. So as you can see here, we're in the dev environment, and we're not going to launch there, so we're going to go over to the live environment. We go to domains and HTTPS, we click connect live domain, we type in our domain, we hit connect. We get some instructions here. Basically, you just have to set up DNS. That's all you do. So you would copy this to your clipboard. You would flip over to your DNS provider's place, and you would paste that in there. And then basically, once traffic is routing to Pantheon, we'll be able to provision a certificate, and it will be live across our global CDN network in over 40 points of presence around the world within an hour. And we're working on getting that time down, but guaranteed within an hour. And there's nothing else you have to do besides update DNS. So that's the idea of making it really easy, and so that everyone can do it. And with that, I would like to turn it over to Josh Aas from Let's Encrypt, so he can tell the story of how they're making this happen for the entire internet.
Thanks, Josh. So I'm going to start off talking a little bit about how Let's Encrypt got started. So sometime around 2012, 2013, we realized we really got to do something more aggressive about getting the web to 100% HTTPS. We should have done this a long time ago, but there's no time like the present to get started. So we started thinking about what we need in order to get to 100% HTTPS, and the bottleneck really seemed to be that it was just too difficult to get and manage certificates. It was difficult in terms of finances, difficult in terms of availability, difficult in terms of ease of use. Like, you had to be fairly technical in order to get a certificate and configure it and set everything up correctly. So ease of use was the biggest issue. So we really designed Let's Encrypt around ease of use. We need to make it so that HTTPS is not much harder or no harder than deploying HTTP. We also don't want deploying HTTPS to be pay to play. When you have to pay too much money in order to enable HTTPS, it makes it so that privacy and security in the web are something that only people with more money can afford to do. So we want to remove that financial barrier. So in order to develop a really easy-to-use system that has a chance at getting the web to 100% HTTPS, we really need a lot of people to be involved. We need people to provide money, so we have sponsors of Let's Encrypt, including Pantheon, that help Let's Encrypt operate. We have a lot of technical people who contribute ideas and code to the various projects that we need. We've got advocates who go out and advocate for HTTPS and try to get specific companies, maybe the company they work for, to switch to HTTPS. And another really important community for us is our support community. So there's community.letsencrypt.org, and if you ask a question, you'll probably get a great answer, and the people who answer those questions are really important. So we can go to the next slide here. So Let's Encrypt is really based around the ACME Protocol. And the ACME Protocol is sort of like DHCP for certificates, if you're familiar with what DHCP is. Let's Encrypt implements what we call the server side of ACME at Let's Encrypt, so at the certificate authority. So we are the place where people request certificates from, so we implement that with a piece of software called Boulder, which is available on GitHub. And then subscribers request certificates from Let's Encrypt using an ACME client. It can be a little confusing that an ACME client runs on your server, but from Let's Encrypt's perspective, your server is the client and we are the server. So we can go on to the next slide. It would be helpful here if I can explain what the 3 different types of certificates are. So the first type is domain validation. And the only thing that domain validation certificates do, but this is a very important thing, is associate a cryptographic public key with a domain. Basically, the assertion that a domain validation certificate makes is that if you encrypt data with this public key, only the servers at this domain will be able to decrypt it. So that's how your browser feels confident about encrypting data and sending it to a server. Domain validation certificates don't assert anything else about a server. They don't assert who actually owns the server, like in a legal sense. They don't assert anything about the content on that site. So for example, they don't know if a site has security flaws or malware or anything like that. We just don't know that. All a DV cert is saying is that you can use this particular public key to communicate securely with a site. And that's a really important underpinning that every site should have. I'm going to sort of lump OV and EV together here because they essentially have the same quality, which is that OV and EV are sort of like DV, but on top of DV, they also include the name of a legal entity. So it might say the name of your company. If you have an EV cert in particular, you might see the name show up in a browser. So Let's Encrypt only issues domain validation certs. We don't validate legal entities. Other CAs do provide OV and EV certificates. There's some debate about how much value those have. Some people see value, some people don't. It's really up to you, but cryptographically speaking, your browser doesn't use anything beyond domain validation. So your browser doesn't understand the legal name of a company. It doesn't do anything except display it. So aside from that name, there's really nothing more secure about an OV or an EV cert. Or we can head to the next slide. This is a quick overview of what issuance via ACME looks like. So the client, which might be your web server, sends a request to an ACME server, which in this case is Let's Encrypt, and we'll send back some challenges. And these are challenges that ask the server or the client to demonstrate control of the domain they want a certificate for. I'll get more into what those are in a minute. But once the subscriber completes the challenges, they send a message back to Let's Encrypt and say, okay, I've done the challenges, now you can come check. So then Let's Encrypt will go and verify that the control challenges were completed, and if they are completed successfully, we'll send a certificate over, and if not, we'll deny the request. We can go to the next slide. So here are the different ACME challenge types. I'm not really going to get into the bottom one, DVSNI. It's not very commonly used, and it's significantly more complicated to explain. Most people use the top 2, HTTP and DNS. So the HTTP challenge is the most common challenge type, and I believe it's what Pantheon is using. So this is where Let's Encrypt will send a special file containing unique contents, right? Maybe a random number or something like that, and we'll tell you to place it at a specific path on your web server, a path that's not likely to be used by anything else. And if you're able to place this particular file that we gave you at a very specific path on your server, then we will assume that you control the contents of that server. So that's basically how the HTTP challenge works. The DNS challenge is a lot like the HTTP challenge, except instead of putting a special file at a particular path on a server, you'll take the contents of that file essentially and stick them in a DNS record. If you can control DNS for a domain, we'll assume that you can control the server for the domain, since you could just point DNS at whatever server you want. So the DNS option is another option. People often will also use DNS for servers that are not available on the public internet, so we couldn't contact the server directly, but we can check DNS records for it. So we can go to the next slide now. There are basically three types of clients that people run to get certificates from Let's Encrypt. The first type is what I would call a simple client. A simple client just does the minimum necessary thing to get a certificate from Let's Encrypt. And once it gets a certificate, it'll pretty much just drop it in the current directory, and then you take it from there. You figure out what to do with the cert, how to configure a web server, anything like that. The second type of client is what I would call a full-featured client. So it's still a separate piece of software. It'll get the certificate, but then it'll also configure your server for you. So it might edit your Apache or Nginx config to set up the certificate for you, and then it might renew the certificate for you every 60 days or something like that. The third type is where we really want to go because it's the easiest thing for people to use. And this is not really a separate piece of software. This is just where Acme interactions are built into the web server for you. So in the case of Pantheon, for example, Let's Encrypt support is just built in. So at most, you go click some buttons or something like that, and then you get a certificate for you, and then Pantheon handles everything. You don't need to configure things. You don't need to worry about renewal, anything like that. So there are other forms of built-in. There's a web server called Caddy that we recommend to people who run their own web server that will just get certs for you. We're working on support for Apache and Nginx as well. But built-in is really where we need to go. It's what makes it the easiest for people to use HTTPS. So a few more things about Let's Encrypt in general. There have been some places in the world where it's difficult to get a certificate. Let's Encrypt, we understand that the web is a very global project, and we want everybody to have the same standard of access to the web. We want everybody to be able to have a secure and private website. So Let's Encrypt works in every single country in the world, and it has since day one. So far, we've issued certificates. Right now we support about 50 million websites, and that number is growing pretty rapidly. So the uptake has been good, and we're really excited about the progress towards 100% HTTPS on the web.
Great, thank you. So now Ari is going to talk a little bit about what we've done specifically at Pantheon with the HTTPS and the global CDN.
All right, thanks Josh and Josh. So yeah, just to give a quick overview of Pantheon's global CDN. This is now a standard offering for all sites on Pantheon, so it just works out of the box. This means that your traffic is served from 40 different points of presence, POPs, around the world. And it really makes sub-second page loads possible. And again, it's included with every plan. It's free. We automatically renew the certs, leveraging Let's Encrypt. And it's all automated. And it's built on top of Fastly's Edge Cloud platform as well. So, you might be asking yourself, whoa, why am I looking at this flow diagram? What's going on here? The main point is we've focused on all of this infrastructure so you don't have to worry about it. So there are a lot of components here. We've built a tool to manage the Fastly configuration, tune varnish, optimize it for WordPress and Drupal sites, automatically provisioning the certs, deploying them out to the CDN. Another component of this is making sure the cache clearing is kind of seamless into the site. So if you click that clear cache button, it'll go and clear all the POPs. So the main point is, there's a lot of moving parts here. You don't have to worry about all this stuff. It just works. And HTTPS is best on a CDN. We've decided to terminate TLS at the CDN. It's really all about the round trips. So like Josh was talking about earlier, TLS in order to actually establish the encrypted connection, there's a lot of round trips. So you can see on the top, without a CDN, if you have to go all the way to the origin, the server, it's actually limited by the speed of light, and it takes time. That latency adds up. So when we're able to put content closer to the user at a pop, closer to whoever requests it, it means those round trips are just going to be a lot faster. So this is, the best way to do HTTPS. It's the fastest. And this affects your conversion rates. This isn't any new. This isn't really news, but it's really important, and it's definitely worth repeating. This affects your bottom line, right? If your website is slow to load, people are going to drop off and disengage. So the faster that you can load the site, the more conversion you'll have, and that'll impact your bottom line. So not only is it automated and super fast, but it's also the best encryption available. So this is what we're looking at here is a Qualsys SSL Labs report. And SSL Labs is the industry standard tool to kind of analyze a TLS connection. And on Pantheon, you can get an A+ now with the new global CDN. So the first step, if you want to make that happen, is for a new site, like Josh showed in the video earlier, you're just going to connect your domain and update your DNS. And that's basically it. You're just going to point your DNS to Pantheon, wait about an hour, and you'll be good to go. Now, a different possibility is maybe you already have, so the first one is you have a brand new site, or maybe a site that doesn't yet have HTTPS. You'll just want to point DNS to Pantheon. But let's say you have an existing site already using HTTPS, but it's not on Pantheon. Let's migrate it over to Pantheon. When you connect that domain, we're going to actually give you the ability to download that challenge file and then serve it from your existing server so we can pre-provision HTTPS. It'll be ready to go for you as soon as you're ready to switch DNS. So we definitely give you that option. You can also see in the bottom right there, you can skip to updating DNS. So you have that option as well. You can definitely skip directly to updating DNS, or you can pre-provision HTTPS. So that's how it works. We've built it so it's easy. And that's the idea. Looking at a few developer tips, the first thing that we want to definitely encourage is that you start with HTTPS. So here you can see a secure, the browser has marked this development environment on Pantheon secure, right? So every environment on Pantheon, whether it's a development environment, test environment, live, they all have HTTPS available on what we call a platform domain. So you can see here it's dev.example.pantheonsite.io, and you don't wait until the last minute when you're going live to start to figure out HTTPS. It's there right away. It's available. So we definitely encourage you to start there. Make sure everything's working as you'd expect. And then another tip is just HTTPS everywhere. Just don't do mixed mode. It used to be, okay, SSL was considered slow. We don't have that problem anymore. It's not like, okay, let's have HTTPS on a login page, but at the other pages, let's keep them on HTTP. If you have any mixed content issues, you're going to want to fix those, resolve them, because that really is a surface for attack, right? If an attacker could actually take complete control over your page if there's one like JavaScript resource that's being loaded over HTTP. So we would just encourage you, again, start early with HTTPS when you're in development, resolve any mixed content issues, and don't do mixed mode. Mixed mode meaning sometimes HTTP, sometimes HTTPS. Just do HTTPS all the time. That way you're going to get that good SEO ranking. Of course, all the security considerations. And we also have some work planned to make this a little bit easier. So new sites by default will redirect all traffic to HTTPS. So definitely look out for that. But So we're excited about that coming down the pipe, but right now you can definitely redirect all traffic to HTTPS. And then the last kind of tip that we wanted to share with you is HSTS. So what HSTS is it stands for HTTP Strict Transport Security, and it's the final step that you would need to get that A+ rating. So basically, what you're doing is from your site, from the server, you're sending a header which instructs the client to only connect to the site over HTTPS. So what this does is it helps prevent any sort of cookie hijacking, a protocol downgrade attack, which could be used in a man-in-the-middle attack. So this is really a best practice to kind of commit to HTTPS. So this is like, don't do this until you're ready to commit, right? This is because what you're going to do is in that header, you're going to say, for 180 days or for a year, only connect to this site with HTTPS. So if for some reason you didn't have HTTPS available, the site would not load. So this is a best practice because, again, it's going to increase your level of security. It's going to allow you to get that A+ rating. But the other consideration is just that it's a commitment, right? It's tying the knot with HTTPS. So yeah, that's basically what we wanted to go over. I think that we can open it up for questions.
All right, we have quite a few questions coming in. Our first one, which is probably a good question I've answered for everyone, is, so I don't need to purchase an SSL cert anymore.
Not on Pantheon, no. And elsewhere on the web, there are lots of ways to use Let's Encrypt, which frees you from that economic burden of purchasing a certificate, what Josh was talking about. I think it's one of the most noble aspects of the project, which is saying we don't want there to be a financial barrier that separates sort of the haves and have-nots from being secure. Security shouldn't be a premium feature like that. It should be a fundamental feature that everyone has access to on the web.
All right, next question. Can you talk about the benefits of using CDN for security?
So the benefits of using a CDN from a security standpoint, there are a few. One is that the CDN kind of optimizes the way the network flows on the back half. So you're kind of routing through more, there's less randomness to the routing, which can have some benefits to security. An important note for Pantheon and the way we've implemented our global CDN is that it is end-to-end encrypted. There are some CDNs that offer HTTPS as part of their service that kind of make it optional as to whether after they've done the HTTPS transaction, sort of they front for the website, and then the back half of the connection might or might not be encrypted. You don't have to think about that on Pantheon. It's just done correctly from the get-go. So it's end-to-end encrypted. There's no point at which data being sent over any network is sent in the clear. In fact, even if you communicate to Pantheon's CDN edge over HTTP, the back half of that transport is still encrypted. So you wouldn't, you want to use HTTPS everywhere, but even if you're using HTTP on Pantheon, half the transport is encrypted. And the last piece would be, it's not related to cryptography, but a CDN allows us to mitigate a lot of attacks that occur on websites, like denial of service or just volumetric attacks, because we've created a much larger surface area which an attacker would need to focus on in order to take down your website. Like effectively, they would need to generate sort of at scale. There's news stories in the recent months about people who hacked like 20,000 Internet of Things, like baby cams, and then they used that to create gigantic denial of service attack that took down Amazon for a little while. Right? Amazon is doing everything pretty well, and so if you can take down Amazon for a little while, I'm not sure that our CDN would do any better. But that's a very rare bird in terms of having hundreds of thousands of devices on a botnet. We talked with Simon from Fastly. He said, you know, you can never say you're invincible, but their network is able to absorb an enormous amount of traffic, which is important as like it becomes easier and easier just to lease a botnet on the dark web if somebody has a grudge against you. But certainly, like, you know, a single web server just sitting on like in the cloud on Amazon, maybe DigitalOcean, whatever. Like, I remember from my days as a consultant, like, there's a fine line between load testing and denial of service, and you could like absolutely crush your own website just by trying to test the load. That gives you a sense of how fragile a website can be without this extra layer of protection. And so, from a security standpoint and from an uptime standpoint, it's a good thing to have.
As a sort of follow-up and to reiterate that, so can the global CDN combined with HTTPS certs help prevent attacks like DOS, DDoS, etc.?
Yeah, I mean that's what we were just talking about. Like basically, it's not really a question of cryptography. It's a question of like network and whether you have like the network, the ability to absorb the brunt of initial attack, and then the intelligence at the network level to mitigate it over time. And the global CDN definitely has both of those features.
All right. Next question is: do we need to do any redirections to force HTTPS?
Yeah, you do, and basically on Pantheon, the way that you would do that is in a config file currently. So for Drupal, settings.php, and for WordPress, wp-config, and we have a new Launch Essentials guide. You can definitely check that out. We have instructions there, detailed step-by-step instructions if you haven't done it before, exactly how to connect and where to put the file and what to put in it. So that's, if you just go to pantheon.io/docs/guides, you can find that Launch Essentials guide.
All right, as a follow-up to that, does this still require jumping from the $25 month plan to the $100 month plan?
Nope, it doesn't. So this is available for all plans, and that's one of the things that we're really excited about offering. You know, this is a core offering. It's available for every single site on Pantheon.
It looks like this one's one for Josh A. That's, will Let's Encrypt work with sites using CloudFlare's free service?
If the question means, so I don't actually know what happens if you want to use a Let's Encrypt cert on Cloudflare today. If the question is, does Cloudflare use Let's Encrypt certs? I don't really have any inside information on that. I don't think they do today. They have publicly stated some interest in using it for at least certain sites in the future.
Yeah, from my understanding, Cloudflare has their own arrangement with another intermediary certificate authority, and they're just like buying in such enormous bulk that they're able to make the economics work such that it can be free for everybody. But I believe they use Komodo as their primary cert authority for their free service. I actually think it would be, there's nothing that would prevent you on Cloudflare, if you want to provide your own certificate, it's actually a premium service because they have to do some special stuff for you. I'm pretty sure if you wanted to, you could put your own, like you could use one of those basic clients that Josh talked about that just like talks the Acme challenge with Let's Encrypt and gets a cert and then lets you, you know, it's still a TLS certificate at the end of the day. You could use it like you could any other, but I don't think there's any practical benefit to doing that because to speaking to those different classes of certificate, you know, a CloudFlare cert is going to be domain validated. You know, Let's Encrypt certs are domain validated. Almost all the low cost certificates that you're going to see, you know, people are used to paying maybe like $10 to GoDaddy or $25 to GeoTrust or something like that. All the low cost certificates are just domain validated, and so they're all essentially equivalent.
I wanted to just add one point to the previous question, which is, so all new sites get this out of the box. If you have an existing site, just reach out to support if you haven't seen the upgrade yet. So that's what I wanted to let you know.
That's perfect. We have quite a few questions on how to get it, so that's great to know. The next question is, you guys had mentioned Cloudflare on one side and Fastlane another. Which one should we be using for HTTPS and Let's Encrypt, which we mostly just answered. But.
Yeah, I think so. For Pantheon customers, you don't have to think about using anything other than Pantheon. We've actually, part of the point of making this all like not an extra economic burden and not any extra work in terms of configuration. It's all assembled for you out of the box. We use Fastly's Edge Cloud platform to deliver the CDN capability, but that's all work that we've done to configure it. Just like we don't actually own our own physical hardware in a closet somewhere. We leverage like large-scale technology vendors on the internet to kind of deliver the Pantheon platform. But the global CDN is like completely integrated, and it just works. So you don't actually have to think about any extra providers to get HTTPS or a CDN. If you want an extra provider because there's some very specific feature that you're looking for, there are good reasons to examine both Fastly and CloudFlare. I think if you were going to do that, and again looking to use HTTPS, you might or might not want to use Let's Encrypt at that point. I mean, at that point, you're going to be spending extra money, and so you might spend some extra money to get a cert that is valid for a longer time frame that you don't have to worry about revalidating. If you are running your own infrastructure, right, you run some stuff on DigitalOcean or Rackspace or AWS or Heroku. Heroku is a great kind of cloud platform for all sorts of different technologies. I think they have a really great integration with Let's Encrypt as well. Basically, if you're running your own infrastructure and you're comfortable with system administration and like configuring your web server, definitely spend some hours investigating your options, because you could probably set up an automatic Let's Encrypt integration on your own time and just stop paying for certificates and stop worrying about whether you can get a certificate for a project or not, because you'll be able to get them from Let's Encrypt for all your future work.
All right, the next question is, can you speak to Let's Encrypt's Wildcard certificates?
Josh, do you want to take that?
Sure. So we've announced that in January of 2018, so roughly 3-4 months from now, Let's Encrypt is going to start issuing wildcard certificates. It's going to work much the same way that it does now. The wildcard certificates will be free. They'll be issued by Acme. The only major difference is that for wildcard, you will only be able to use the DNS validation method. So you'll have to validate using DNS records in order to get wildcards, but the DNS validation will work exactly the same way as it does for non-wildcard certificates. So we're excited to put this out there. We think it's going to help get us a little closer to 100% HTTPS a little more quickly.
All right. Will we ever be able to do challenge file over HTTP to an existing domain?
Yes, so that's Ari kind of went past that in his explanation of how it works. The first option is, you have a new site or you have a site that doesn't yet have HTTPS. Just point DNS at it. There's like no security risk, and it's just much easier to do that, and you'll get a certificate and you'll be on HTTPS or have HTTPS available within an hour. If you have a website that is moving to Pantheon that already has HTTPS enabled, that's exactly what we do. We'll interact with Let's Encrypt and obtain the challenge file and then provide it to you, so you can just put that file on your existing site and be able to get that past the Acme challenge. You're kind of like demonstrating the Acme challenge behavior on the behalf of Pantheon, who then will receive the cert from Let's Encrypt and provision it for the Pantheon platform for the domain that you intend to move, so that there's no interruption of service. Basically, this is as I explained it, you can imagine there's a lot more steps to doing that. So but it's worth it if you want to ensure uninterrupted HTTPS service. It takes a little bit more effort. If you don't yet have HTTPS service, there's not really any reason to go through all those extra steps. Just point the DNS and you'll be good to go in 60 minutes or less.
To clarify, what is the difference between an HTTPS site that indicates problems with images and one that is fully secure? I saw the error message at the beginning of the lecture. That's the reason I'm asking.
Do you want to take that, Ari? That's I think mixed mode, probably.
What is the difference between
between an HTTPS site that indicates problems with images and one that is fully secure?
So if you're yeah, you'll basically not get that green lock in the browser, right? So if you're visiting a site that's loading any resources over HTTP, you're not going to get that full green lock. It could just be images, it could be JavaScript, it could be whatever it is. So to fix that, basically, you'll probably need to do some sort of searching and replacing, maybe in your database, changing HTTP to HTTPS. In the Pantheon dashboard, if you're cloning your database from one environment to another, there's actually some drop-downs there that can help you do that conversion from HTTP to HTTPS. And then we also have a command line tool called Terminus, which allows you to do some search and replace. That way, you can use WPCLI on the WordPress side. You can. We also have a doc that can help with that. It's called switching your site from HTTP to HTTPS.
And then just the difference is the way it's supposed to work is when you request something, when a browser requests something like yoursite.com over HTTPS, it's going to assume that it wants to say, I'm going to use HTTPS for all of my requests. Because again, otherwise you have the risk of the primary request being encrypted, but all the subsequent requests, if any of them are made in the clear, all those privacy concerns around metadata leakage and so forth are present there. And so you don't want to do that mixed mode approach where some things are on HTTP and other things are on HTTPS. You want to get to full HTTPS everywhere, and that's the only way to get like the A+ rating.
If for some reason after launching HTTPS we needed to revert while testing, is it a fairly easy process?
Yeah, we don't shut off HTTP, right? The HTTP is always available. You can always talk to the things on port 80, and it would, in many ways be problematic if you couldn't. So really, the question is, what is the method that you're using to kind of shunt all traffic from the clear channel to the encrypted channel? The only exception would be if you've made that commitment via HSTS that Ari was talking about. So what HSTS will actually do is your browsers will notice, and in fact there's the potential for the browsers to actually report this back to the browser makers and them to include this data in future updates to browsers. And once the HSTS commitment has been made, once that assertion is out there, it actually can get you out of some of the mixed mode challenges, because what it means is the browsers will automatically just use HTTPS. Like even if the link on your site still says HTTP, if a user clicks it, the browser will say, no, that's a URL for a site that's made the commitment. I have my history here that says this is an HSTS site. We're going to go all in and just automatically change the request on the fly on the browser side to HTTPS. And that's why if you ever fall out with HTTPS, HSTS can be risky because the browsers will basically not be able to browse your website. So if you make the HSTS commitment, then you wouldn't want to have, you would basically have a hard time in a dev mode switching out of it because you'd have to, there's probably some way to do it, but you'd have to like get your browser to forget that it ever happened, and that can be a challenge. But otherwise, it's just up to however you're handling the redirects and what you're doing with URL rewriting, if anything at all.
All right, next question. Is it necessary to update D7 settings.php in my Pantheon sites already running in HTTPS?
If you're already running in HTTPS, then there should be no changes needed to use the global CDN and Let's Encrypt, other than updating your DNS, because if you're a legacy user of our old HTTPS infrastructure, your DNS is pointing you at not at the global CDN. So if you're a current HTTPS user on Pantheon, you should immediately or at your nearest convenience go to your site dashboard, go to the live environment, and see the DNS, the recommended DNS change that's there, and make it. Because then you'll start using the global CDN, you'll get the performance benefits, you'll get the security benefits, and you'll never have to worry about renewing a certificate again.
And if you do have an existing site on Pantheon and you still have the old legacy interface, it'll look like you have two separate tabs, one for domains, one for HTTPS. So if you have that, where there's the two tabs, one for domains, one for HTTPS, just open up a quick support chat and we can get you upgraded to the new interface, which will give you a combined domains and HTTPS tab, and that's where you'll see if any DNS DNS changes required for you to be on the new shiny.
Yeah, and we're working on ways to make that more visible, like in your user dashboard, if you're an agency or organizational user at Pantheon, at that, like, kind of wherever you see a list of all your projects on the platform, we'll be kind of flagging the ones that haven't yet been upgraded, so you just know where to look and what to do. But if you know you have a site that's using HTTPS and you know you're using the old infrastructure, upgrade today. It only takes a minute, and it's very well worth it.
All right, Josh, I think this question is for you, and that is, so what, if any, disadvantages are there with Let's Encrypt versus other conventional certificate authorities?
All right, so Let's Encrypt offers certain services, other certificate authorities offer other services. Basically, the certificates that you actually get are the same. I don't think there's really much difference in the DV certificates that you would actually get from one certificate authority or another. I think the main reason that you might want to choose another certificate authority is if you want other services that they offer. For example, if you want a paid support plan, or, you know, we don't sell a paid support plan really. They may sell other services associated with certificates. I don't think there's too much difference other than that. They may have different ways of integrating with your software, or maybe you're using a company for other services that has integration with another CA. But again, when it comes down to the certificate itself, they're really, you know, DV certificates are really all the same. There may be some differences in terms of OCSP response time and things like that, but most CAs have things like OCSP on a CDN, so they all perform roughly the same. I hope that's a good enough answer to that question. It's kind of
one note, and I'm thinking, like, so when you did the slide with sort of domain validation versus the organizational or extended validation, I think I sort of like two comments, and maybe tell me if I'm wrong about either of these things. The first one is, I think there is, like, if you're in the world of domain validation, which again is most people's experience with most certificates, I think I could see one benefit being, if you had to do it manually, you can buy a domain validated certificate from, like, again, from like GoDaddy or something like that, and buy it so that it's good for 4 years. And I think that for Let's Encrypt, because it's designed around automation and frequent refreshing and renewal as a kind of a best practice, there is a shorter maximum expiration time. Is that correct?
Yeah, that's a really good point. So Let's Encrypt certificates are only valid for 90 days. And the reason for that is Let's Encrypt certificates are designed to be automated. And if renewal of your certificate is automated and it just happens, then it really doesn't matter how long the lifetime of the cert is. The reason that our certificate lifetimes are shorter, though, is important to understand. There's this concept of revocation, that if something goes wrong, if your private keys are exposed, that you might want to revoke a certificate. The problem with revocation is that it doesn't work very well. Chrome, for example, doesn't check revocation status at all. So if you revoke a certificate, Chrome is not going to notice that. It's just going to assume that the certificate is still good until it expires. The consequence of this is, if something happens to your private key, your certificate is still good essentially until it expires, even if you revoke it. So maybe people might remember a while back that there was this attack called Heartbleed, where a lot of private keys got exposed. The reality is that if your private key got exposed through something like Heartbleed, you're vulnerable until your certificate expires. So while it might seem convenient to buy a certificate that has, you know, a 2-year lifetime, the trade-off there is it's less secure, right? If your key is exposed, you're now stuck with that for 2 years, and there's not much you can do about it. So Let's Encrypt limits the lifetime of certificates to 90 days for security reasons, and we do think that shorter lifetimes are safer. But I understand that some people, you know, need for various reasons the convenience of a longer lifetime certificate. So if you do need one of those longer lifetime certificates, or you feel that you need that, that's certainly a reason to look elsewhere, because we don't offer that for the reasons that I just explained.
And then the other thing, I mean, and Ari and I, we've talked about this before, like in terms of people who those extra layers of validation, you know, you're very diplomatic about, you know, reasonable people can disagree about whether they provide extra value. And I'm sure, you know, reasonable can disagree. They're fairly expensive, and I would just point out that, again, from before, Amazon doesn't use them. And if there was any tangible business benefit to having the OV or EV certificate, if it was like a 0.001% increase in sales as a result, you know Jeff Bezos would be all over that. Amazon doesn't use it. Google doesn't use it. Like these are basically kind of, I think of them as kind of legacy sort of processes for the internet, where it's like, you know, it's kind of a bureaucratic process where there's going to be somebody's going to call the phone number associated with a domain name and validate that there's a person to pick up on the other end of the phone, and then that gets you some, you know, that shows that there's something more there. But we can see from the way that like really large scale players on the internet work, it doesn't really do much, like because if it did, they would all be adopting those things, and frankly, they're not. And I think most people work with domain validation anyway.
I can add a couple points about that. I do think, you know, again, there is a diversity of perspectives on the value offered by OV and EV, and I totally understand people want to get them. I think the research around it suggests that one of the main issues is that people don't notice the absence of an EV cert, right? So if you go to a website and you see a regular lock as opposed to the EV UI, you probably aren't going to remember that you were supposed to see the EV UI as opposed to just the lock, right? So not noticing the absence of EV is one of the issues with the security of EV.
Yeah.
One other benefit that I think of the 90-day expiration of Let's Encrypt certs is that Let's Encrypt will refuse to renew a cert if Google's marked the site as unsafe. So one of the cool things about Pantheon is you can have one site on it, 10 sites, 100 sites, you know, hundreds of sites. So we'll actually, if we're going to renew your cert well in advance of expiration, if Let's Encrypt refuses to renew it, then we're going to work with you to address the issue. So maybe, you know, you didn't notice that Google marked it unsafe. We're going to work with you to, you know, remove the malware, let you know so you can make your site safe, keep the cert renewed, and, you know, keep your customers happy.
Alrighty, guys, and one note before we log off here, we will be sending this recording out, and in addition to that, I will make sure we include all the docs you need to get yourself well informed with all these amazing updates we have. But beyond that, if you have any other questions or feedback, please visit our website where you'll find a Contact Us page, and we'll put you in touch with the best member of our team. And thank you again to our guest star, Josh. We loved having you on site, and thank you, Josh and Ari, for your presentation as well. Have a great weekend, everyone.